All right, so what are the dots in this table?
Electron?
Which electrons?
Valence.
Yeah, the dots are valence electrons. That's what they are, right? Basically, this is a small periodic table with the valence electrons represented by dots. And so you look, everything in group 1, hydrogen, lithium, sodium, potassium, and even the rest of the row down, rubidium, cesium, francium, they're all going to have one dot, right? Because they all have one valence electron. All the group 2 ones have 2 valence electrons. All the group 3, aluminum down, have 3 valence electrons, and so on. All right, so we're going to use these so that with chemical reactions, we can figure out how many of each things have to react to form ionic compounds. All right, so this is what it's going to look like. Let's say we want to do, so this would be reactions with dot structures. So let's say we wanted to look at a chemical reaction between, let's say, lithium and chlorine. Okay? And you know this is going to produce lithium chloride, so that's obvious. The question is, what's going to be the formula for lithium chloride? So just to take a second before I draw the dots, to insert some reality here. So we have a piece of metal, lithium, soft metal, right? We throw it into a jar of some yellow gas called chlorine gas. It's going to react. This is going to look like the reaction when I threw the sodium in water. It's going to be sparks and stuff. And it's going to produce this white salt at the bottom, and that'll be the salt called lithium chloride. Okay, so the question is, what does this reaction look like? So let's write lithium here, Li. Let's give it the little dot that it gets. And then chlorine. And how many does chlorine get?
7.
7. Right, 7. And we tend to do 2 on top, 2 on the bottom, and 2 on each side. Well, not 2 in this case because it only has 7, but that's how we like to do it. And so the last one that goes there would go there. All right, so when these two react, what's going to happen is this little electron from lithium is going to leave, is going to get taken away by chlorine. And then we're going to end up with basically a lithium with a positive charge, a chlorine with a negative charge, and so they're going to stick to each other because they have opposite charges. It's going to form lithium chloride. So far, there's nothing really exciting here. But let's do another one, and I want you to see what happens when the numbers are a little bit different. This chlorine got 1 electron, right? So it was filled up. It had 8 valence electrons, and 8's the magic number. They all want to fill up to 8. Okay, so what happens when instead we do lithium reacting with oxygen? How many valence electrons does oxygen have?
6.
6. 1, 2, 3, 4, 5, 6. How many does oxygen need to have a full outer shell? 8. So how many does it need to gain here? It needs to get 2. And this is the point of the whole lesson, so make sure you get this. Oxygen needs 2 electrons. This lithium only has 1. It's going to take 1 from that lithium. It's going to have 7. Now what happens?
You need 1 more.
Where's it going to come from?
Oxygen.
Another lithium. Another lithium is going to bump into this oxygen, and it's going to give up an electron. Remember, we got a block of metal here. It's not just 1 atom of lithium. It's 10 to the 22 or 10 to the 23 or something. A huge number of atoms of lithium. So that oxygen is going to find another lithium. It's going to take its electron away, and then it's going to have a full outer shell. What this tells us is that when lithium and oxygen react, the ratio in lithium oxide is 2 to 1. 2 lithiums for every oxygen. Has to be 2 lithiums for every oxygen so that oxygen can fill up its outer shell and the lithiums can lose their outer shell. And that's where that lithium comes from. All right, let's do another one. Let's say we have magnesium reacting with oxygen. How many does magnesium have in its outer shell?
2.
This has 2. I'll put them on opposite sides. I like to do that, right? Because electrons repel each other, so you shouldn't really put them next to each other. How many does oxygen have? So really, this has 2, oxygen needs 2, so this magnesium has enough electrons to fill that oxygen's outer shell. So we only need 1 magnesium to react with 1 oxygen. So the formula is just going to be MgO, 1 of each. And when there's 1s, we don't write 1s in chemical formula. We don't put little 1s down there, because obviously if it was 0 magnesium, I just wouldn't write it. Right, so 1 is implied. All right?
It's only for like the single valence electrons, like.
No, not necessarily. I'll show you an example where that's not going to happen. So let's say instead we have, let's do calcium and bromine. So it's going to make calcium bromide. How many valence electrons does calcium get? 2. 1, 2. How many does bromine have? 7. How many can this bromine take? 1. Just 1. It only needs 1 more to get to 8, right? What's calcium going to do with its other electron?
It's gonna do CN1.
Yeah, you don't have to write the 1. Yeah, another bromine is going to find this calcium, it's going to pass by, and it's going to take the other electron. So we're going to need 2 bromines for every calcium. So this one's going to go to a second bromine. Because calcium has 2 electrons, it has to react with 2 bromines. So we're going to have CaBr2. 1 calcium, 2 bromines. Questions so far? Should I do another one?
Yeah.
Okay. Let me erase up top. Does everybody have this?
Yep.
Let's try one with more. Let's try aluminum and bromine. Okay. How many valence electrons does an aluminum atom have? 3. Bromine's got 7. We just did that. So bromine can only take 1, right? So what needs to happen here?
You have to have 3 bromines.
Yeah, 2 more bromines have to come along, and they both have to take an electron away from this aluminum. Oops. That one goes there, and then this one's going to go to this bromine here. So there we go, because bromines can only take 1, so we need 3 of them to take those 3 electrons away. And this, this is what happens in real life. This keeps happening until you run out of one or the other, right? And when you run out of one, the reaction stops. So our formula for aluminum bromide, AlBr3. How many people get this?
Wait, why is it 3?
Because I need, bromine has 7 valence electrons. The magic number is 8 to fill up. So it can only take 1 electron to fill it before it's full.
Okay, well, why was it going to be 2 if the first one is already filling the shells?
So aluminum has 3 electrons.
Yeah, I
gives us
understand it.
one.
Like, I understand what you're saying. I just wanted to find.
You mean, okay. I don't understand the question.
Yeah.
All right. Does anybody else understand so that I can explain? All right. Should I do another one?
I want to do it.
Good?
Yeah.
Sure. Okay. All right.
Worksheet time.
Almost me.